welcome back to the wrap-up of the module that has been dealing with operating systems, virtual memory, and I/O devices. I/O devices that we have talked about so far generally deal with the devices that are within one machine, one computer. Disks, keyboards, mice, displays, and so on. Do we do something different to connect our computer to other computers through networking? Well, it's all done on the same principles. So let's just quickly recap. What do we do with the networking? So the idea of networking started originally to share devices between the computers, like printers in the office. Then people started getting much more interested in moving files between computers. Instead of just copying them on a device that we used to have that was called a floppy disk, you could just send them directly to another device by using FTP or file transfer protocol. Then they figured out that it don't have to be like typed up files about some documents or a presentation or something like that. People started using email. Then we started communicating between the networks of computers. So we ended up with file sharing networks, World Wide Web, and many other things that run today's world. How did the internet start about? Well, it started with ideas a long time ago, around 1962. Lick Leider, also known as Lick, while he was at DoD's ARPA, which is nowadays DARPA, wrote a memo describing a desire to connect computers. And he was targeting actually a research network that would be connecting computers at Stanford, Berkeley, and UCLA. In 1969, so-called ARPANET debuted and connected computers at UCLA, SRI, Stanford Research Institute, Utah, and UC Santa Barbara, not Berkeley. Then Robert Kahn and Vint Cerf invented TCP, which is now part of the Internet Protocol Suite. This is a way how the computers talk to each other. Internet, from day one, this desire to connect computers was very appealing, and Internet has been growing exponentially from then until now and into a foreseeable future. World Wide Web came around when I was in college, 89, and it was clunky early on. It was implemented by Tim Berners-Lee, started at CERN, and then I think Tim moved over to MIT. It was called the System of Interlinked Hypertext Documents on the Internet. The idea originates early on to Vannevar Bush, one of the really big computing pioneers, that envisioned a system like that but did not implement it. Tim Berners-Lee implemented the HTTP client and server using the internet. It didn't take very long for the whole world to explode. We witnessed the dot-com boom and the bust after that followed in 2001, but everything recovered and we have access everywhere. So what is behind the protocol there? Generally, we send packets of data. These packets of data are produced by software. The software will, the software application will copy the data to the OS buffer. OS will calculate some kind of a checksum such that if there are errors during transmission, because when data go on a far or long trip, some bits may get corrupted. start a timer, and then OS sends the data to a network interface, a hardware network interface, and says start. The data is packaged in a particular way, as is shown here, that has its address of the destination, of the source, the length, because some of these packets may be variable length, has some acknowledgement info, and the payload, which may be commands, addresses, or data. And finally, has a trailer in the form of a checksum in the end. Now, on the receive side, the data will show up in another network interface. That's a special card, and will be transferred to the operating system buffer. I think you're guessing how it would end up being transferred to the OS buffer. OS will check if the checksum is correct. If it matches, if it is okay, it will send the acknowledgement back to the sender. If it is not okay, then it will delete the message, and the sender is going to send it again. Sender is also going to send it again if it does not receive an acknowledgement after the timer expires. If everything is okay, the message has been received, and the OS will copy it to the user space and signals application to continue. And I think we all know the mechanisms how to do that. What do we need in order to implement all this wonderful thing? Well, we know everything. Traditionally it is done using a network interface card. And it's a card like this one that you will find nowadays in servers. If it is a laptop, it really shrunk to something that is just a chip on a board, and you will generally find the wired or wireless interfaces. How is the data transferred? In some older cards, it was done by using programmed I/O. In newer cards, it's a DMA. So the DMA is the mechanism to transfer data that is going to go on a long voyage over the internet from the main memory. And the same way, when it arrives to the destination, its network interface card is going to use DMA to transfer it back to the memory. And that's it. We have concluded this module. We have actually done something, again, another big step. We have figured out how computers work. I mean, I know that we all know how the computers work, but we now really know how they work. We also figured out how does the OS work and how can we interact with it. We do have to take more classes to actually write an operating system, but we may not need to do that. We may be happy with just knowing how to interact with it and pick some other classes. But OS classes are cool. We have also, in the process, built a virtual memory system and figured out how various kinds of physical devices work and why do we have such huge differences in speeds and affordability of different classes of memory. So we got physical reasons why we had to build this big memory hierarchy, such that we can build this illusion of infinitely fast and infinitely big memory system. And in the end, we figured out how to attach peripherals to perform input and output, and the same mechanism is used for connecting disks and Ethernet cards to connect to the rest of the world. That's it for this whole module. We'll see you in the parallelism module after a longer break.